Michael, because that's my dad's name. Okay, hi, we're reviewing. We are going to finish reviewing this portion right now, which is optimization. It got cut off a little bit, but here we go, optimization, okay? This is optimization, right in here, optimization. Yeah. So, each one of these videos is like sectioned up. All right, so when you're doing an optimization question, the first thing that you want to do is draw a picture. And if they already have a picture for you, then hooray for you. But you want to draw a picture if there's nothing there. Then what you want to try to do is generate the optimizer and the helper. So the optimizer is going to be what equation you are trying to find the max or min of. And just read the question. It'll be like, what is the largest area you can build with 100 feet of fencing? So maximum area, you're like, oh, ding, 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 that's my optimizer. I'm trying to generate a function that represents area. I'm going to get it all in terms of one variable using my constraint, which is your helper, right? So that's why I always say look for the constant, because he's usually your constraint. Given 100 yards of fencing, given the volume of this cone only holds this much water, like it'll be a constant and it'll help you get it'll help you get the optimizer in terms of all one variable. Why do you need to get the optimizer all in terms of one variable? Because depending on the nature of the question, you're either going to have to graph it and find the max or the min, and you need it all in terms of one variable to graph it, or you're going to need to just generate it by hand, take the derivative, set it equal to 0, and find the max or min manually, okay? So step 3 is going to be get the optimizer all in terms of one variable so that you can take the derivative. You will then confirm your max or min with a number line. Then step 5, write your answer in a sentence. Why? Because it just helps you check that you've answered the question correctly. Or it doesn't necessarily have to be in like a full sentence, but just double check, like sometimes you think you found the x coordinate and then the question says find the y coordinate, right? So that's what I mean by like double check and make sure you're answering it the way it was asked. So the review question that goes along with this topic would probably be question 10. The reason why I picked question 10 is because we need to make the picture. There is no picture here, okay? So question 10, it says, an isosceles triangle is drawn with its vertex at the origin and its base parallel to and above the x-axis. So that tells me this thing's going to be facing downward. And the vertices of its base are on the curve 12y equals 36 minus x squared. Determine the area of the largest such triangle. So my helper is a little confusing because I can't quite conceptualize what that would look like. So I'm going to divide each piece by 12. And I'm going to have y equals 3 minus 112 x squared. And I'm like, oh, okay. He's a downward facing parabola and he's pretty wide. He's a downward facing parabola. He's pretty wide. And underneath he's got... There we go. And underneath, he's got an isosceles triangle. Its vertex is at the origin. And this distance here would be x. This distance here would be x. So just be careful because the base of this thing is going to be what? 2x, right? This is y. And then y, we just solve for y kind of. So we can just be like y equals 3 minus 1/2 x squared. And that makes perfect sense because this y will be dictated by when we like move the vertices. So it'll just be y equals 3 minus 1/12. Oh, did I not write the 12? X squared. So anywhere along that curve is going to generate the y, the vertical distance. Okay, now it says determine the area of the largest such triangle. Okay, so I am trying to find the area of this thing, right? What's the area of a triangle? Mm-hmm. Okay. And if I try to substitute in what I've got so far, the base is 2x, right? Because there's two of them. And then the height is going to be generated by what? Y, right? So I'm going to be like, okay, the height is going to be 3 minus 1/12 x squared. So couldn't I just kind of plug that guy in for the height right over here? Yeah. Okay. And then now if I wanted to do any further working, I have to find the derivative of this thing. So I'm like, going to cancel that right there. And I have x. I'm going to distribute. And then now I'm going to take the derivative. Okay. Then now I'm going to set this derivative equal to 0 because I want to see if it is a maximum. Largest such maximum. Okay. Set it equal to 0. I'm going to add the 1/4 x squared, so now I'm always dealing with a positive x squared. And I have 1/4 x squared equals 3. Multiply both sides by 4. Huh?
Nothing, I did something wrong.
You're good. Okay. So then I'm going to square it. Let me know if you figure out what it's going to be. Rad 4, rad 3, 2 rad 3. Okay, so now I'm going to take 2 rad 3 and put it on a number line. You would get positive or negative, and then we're going to put it on our number line, right? It looks like it doesn't matter because it doesn't specify. Like on that one question that you did on the review, I believe it was like this is R and this is Q, and it was like what's the Y coordinate of Q? Then you would have to take the negative, right? For simplification purposes, since it doesn't specify, I'm just going to take the positive and test it on the number line, okay? They're symmetric, so it's not specifying which point I have to pick. Does that make sense, just to simplify? Okay. So now, you could also bound these if you want, like if it's bound, you also don't even have to, so just whatever. All right, so we're going to do, I don't know, 2 and 4. Let's test 2 and 4. We're going to plug these 2's and 4's into the first derivative. So I'm going to have 3 minus 2 over 4 is 1, or 1/4, and then 2 is squared, so it's 4 over 4, 3 minus 1, this guy's positive. And then 4 would be 16 divided by 4 is 4, that's a negative. So this is in fact a maximum. And then it's saying that I want to determine the area of the largest such triangle. So now I have to take, that's why this last step is crucial, because you want to make sure that you answer the question, right? It would be very tempting to just write x equals 2 rad 3 and that's your answer, right? No. Because they're symmetric and it doesn't specify which point I'm supposed to pick. So if it was like this is, stop. So if it was like this is R and this is Q, what's the Y coordinate of Q? Then you would have to like make a call of like which quadrant I'm in. But since it's symmetric and it's just like they're the same on either side, I'm just going to pick the positive one to simplify. So I'm going to sub in a 2 rad 3 to find this maximum area. So the area function is going to be 1/2 base times height. Hold on, I'm going to scooch this guy over. And it actually looks like this guy is like the simplified version of whatever I'm about to do, so I'm just going to plug him into that one. So I'm going to do 3 times 2 rad 3 minus 1 over 12, 2 rad 3 cubed. So then now I've got 6 rad 3 minus. Okay, so this guy's going to be rad 3 cubed. Let's think about what rad 3 cubed looks like. This is 8. So I got rad 3 times rad 3 times rad 3. This becomes a 3, so I got 3 rad 3. So 8 times 3 rad 3 is going to be what? 24 rad 3 over 12. So then now this is going to become 2 rad 3. So I have A is equal to 6 rad 3 minus 2 rad 3. So this guy is going to be equal to 4 rad 3 units squared. Yes.
I thought it was wrong.
That's it on optimization. Bye.